Now I would like to invite the next speaker. And now we are going to hear about monitoring of land subsidence in Nigeria. And the paper is presented by Philippe Conroy, right? No, another Philippe, yeah. Yes. Yeah. Good.
Thanks so much.
The floor is yours. You have the pointer.
Yes, good morning, everyone. And unfortunately, Femi, who's in the picture here, is not present at the conference to present this work himself. He's the lead author on this, this contribution, which is actually the inception study of a program that we have in the west coast of Africa. So before we dive into that, I'll give you a brief overview of this, this program. So we recently started the Engulf program, which is land subsidence along the African's Gulf of Guinea coastline, together with Pietro Teatini of University of Padua, and it is funded through the AFD, which is the French development agency. And we are working together with several institutes in different African countries along the coast with local researchers over there. And Femi is part of that, and he's from the University of Lagos in Nigeria. So first, the rationale. Land subsidence, it's actually a global threat, as you may all well know. And here we see some INSAR maps of different coastal deltaic areas around the world with all rates, and these are all, some of them are all quite a bit older, so present day rates may have changed or probably even accelerated in some examples. So it's really high rates, and as we also know, is that humans are actually sinking these coastal lands much faster than as sea level rises, as we also saw in the presentation this morning, right, by Gilles and also highlighted by Michiel. Humans have a really fundamental footprint in accelerating land subsidence along the coastlines. So knowing that we are doing those kind of stuff, let's have a look at the projections of global population in the world. Well, it's very distinct and clear that the African continent will be the booming place of the increase of population in the next decades. So this is going to be a hotspot of economic development, socioeconomic change, and also probably likely impact on the environment, as also the coastal environment. Well, then specifically, if we go to this stretch of land, let's say the belly of Africa, there are several large delta systems, coastal systems, and actually all the booming megacities, they're all located on the coast, right? All these megacities of millions of people with projections that go through the roof, they are at the coast. So we're actually very interested what's happening there at the moment, and of course what will happen in the future. So luckily, there's this great paper of the LASI research group that mapped the global threat of land subsidence. So if we take that resource and we zoom in, actually, unfortunately, we see that most of the area is hashed out. What white hashes means there's actually no data available. So we don't really know what's happening in this region. And knowing that it's going to be this massive boom, that actually set us to build this Engulf program, to actually start looking at these issues for this region. So here we see one of the products of the inception study for the stretch of coastline. We're looking at, this is the elevation. It's an analysis of recent elevation models. And we try to find out what are the low elevated hotspots where potential land subsidence or accelerated sea level rise could affect, let's say, the people living there. Well, and we see these hotspots around indeed the big deltas and also these big megacities from in the different countries. And in this talk, we're going to look at the Nigerian part, so mainly Lagos, but also on the Niger Delta. So the specific motivation for the study of Nigeria, well, several factors play a role. There's groundwater extraction, there's actually also a lot of mining and industrial oil and gas extraction going on. There's a lot of oil, there's over-extraction of water, there's highly compactable sediments if we have this big delta, the Niger Delta system. And therefore there's an increase of floodings happening, and this is experienced by the people living there. And to date, there hasn't been, let's say, a study that really looked into land subsidence and linked it to relative sea level rise for this region. So one of the things Femi did was, first he started to do a literature research, simply looking at different keywords that are present for literature for the Nigerian coastline. And he was able to find, let's say, several articles, but actually it's not much if you look at that. There's only 10 articles mentioning land subsidence. There's only 4 of them linking it to coastal vulnerability. And there's actually none linking it to sea level rise. So we are really talking about a data sparse and a little studied area in the world. Fortunately, there are some studies now done, and here we see most of them are INSAR studies on what is happening for several parts of this coastline. So on the left upper corner, we see INSAR studies for the city of Lagos. And then if we go to the right side, we also see some INSAR and modeling studies for places in the delta. And these are mainly oil and gas extraction areas. Well, here there's a list, a summary of different investigations that have been done. So for Lagos, there's been 4 studies. They're all based on INSAR. And as you can see, there's quite a big dispersion of, in this case, maximum subsidence rates. And I would say, okay, there are studies available, but there's also quite a high level of uncertainty, I would say, related to these rates that are reported here. So they are indicative. There is things happening already, but how much actually is happening, well, that's to be seen yet. But it highlights that at least this is a problem in this region. Then if we move down, okay, there's the second part, Port Harcourt area. This is on the east side of the Niger Delta, the east of the country. Well, we see a, I would say, ridiculously high rate of land subsidence right there. This rate is actually linked to the analytical modeling that we see in this table, and actually we have high doubts about this study. It's a reservoir model, relatively simple, and an extreme scenario. So I wouldn't take that value to heart because it will be really extreme. There is some ground leveling there in this region that helps us to actually constrain. So let's say the 200 millimeters per year, 20 centimeters per year, that is indeed shown by also surface measurements. So there's high rates of land subsidence happening in that area. Let's have a look to the spatial temporal trends that have been found for an INSAR study by Femi himself for Lagos. And as you can see on the top, he used both Sentinel and Envisat. And well, at least the areas where we found the land subsidence rates, they are in sync. So we have this coastline stretch, which is also a large barrier island where a lot of the economic activities are taking place. And then there's a more inland area, which used to be a lagoon that has been filled in, where also the city is expanding these days. There is a bit of, there's one GPS station present now at the university campus, and that shows, as you can see, well, a gradual displacement. We see the seasonality nicely in that record, and a subsidence rates of not very high in this particular place, but on average, it's a short record, only a few years, but we see 3.3 millimeters per year going down. And if you compare to that to the line of sight at the same place of the GPS, there's some correspondence there in the signal. So we are on the right track. But unfortunately, this is the only place where we could tie the INSAR until now. So this is a point that we hope to improve as well. So the spatial temporal trend in the Harcourt area, again, this is in the east of Nigeria, on the east side of the Niger Delta. And here there are several places where there's a very, I would say, high rates of land subsidence going on. We see rates there up to 50 millimeters per year, so it's really in the order of centimeters, multiple orders higher than sea level rise. And what is actually interesting, and well, I asked to Femi, why do we see these rates, and why do we see a declining trend? Is there anything happening in the driver that is causing this, right? And according to him, well, he says it's highly likely due to the extraction of oil and gas. But what's really happening there, if there's indeed a gradual slowing of the land subsidence trends, that is something that we want to look into further. But at least it gives us some hinges for what we're going to do in the next years. Well, then some images. And yes, subsidence is a very slow process, but it can be for, let's say, individual people quite a catastrophe. In that sense, here we see actually buildings that are tilted and that are permanently flooded and well, not all already abandoned, but people move to the next level in their house. But of course, this is very harsh living conditions, and this is happening in the mega city of Lagos at an increasing rate that buildings are damaged and lost due to land subsidence. So the identified knowledge gaps, well, there's no comprehensive paper that really sums this all up. So that's what this contribution tried to do as preliminary work. We lack in situ data on the subsurface, what's happening in terms of hydrogeology, in terms of extraction of groundwater, of course, in terms of extraction of oil and gas, but that's also highly protected and sensitive data, especially in a country like Nigeria. So yeah, let's see how we can address that in the future. And there's the critical absence of GNSS stations, which we need to really calibrate and validate the INSAR measurements. So the next steps that we hope to do specifically for Lagos is to to actually try to find what data is available on the subsurface. We don't have the budget to do drillings, etc., but of course there is data scattered around, hopefully with local institutes, maybe oil and gas companies that we can try to extract from them and use. We want to see what we get from the data in order to help us setting up numerical models focused on the drivers at hand that we think are causing issues here. And using that, we want to move towards these process-based projections of land subsidence for this growing megacity, which is something very highly interested by, for example, the World Bank having large infrastructural investments in this country. Also, the municipality itself, they are very actually starting to worry about this issue. So the idea is really to try to be ahead of the Jakarta scenario, which is, well, I would say further down the line in a sinking city. So that's what we try to be in advance, and hopefully we can steer the trajectory of this mega city in a different direction. Let's see what we can do. And then the fourth point is to try to set up GNSS stations to really improve the ground truthing and the monitoring on the surface. But for that, we don't have the funding yet. So if you're interested and have a bag of money available, then please join us. And another thing, this is more the larger and Gulf program. The aim is to build a community of interest for this region in West Africa and really empower local researchers in this subject so they can carry the collection of knowledge forward. Let me see. Okay, it's a bit of an older version. So this is again a recap. So let's go to the second part. Of course, within the program, we also look to other hotspots that we identified earlier on in other countries with other universities. And then the last point is we aim to host the first West African coastal regional workshop on land subsidence. And this is tentative for next year. We're eyeing Ghana, English-speaking country, relatively stable, or actually stable. So that's something you can also travel to. So this is also a shout out for people who are interested in working in this region or are working in this region to keep an eye out, and we will surely communicate this also through the LASI channels. And we hope we can set up, I would say, a regional center of community of interest on this important topic. With that, I thank you very much for your attention.
Thank you, Philippe. Do we have questions? Yes, I'm coming to you.
Thanks, Philip. Appreciated that. So I work at a delta in the Mississippi Delta where saying that oil and gas extraction is causing subsidence is actually quite controversial, and there's been a lot of pushback. So have you had successes in being able to parse out the different drivers and mechanisms in the different regions to say this percentage is natural, this percentage is from groundwater extraction, this percentage is from oil and gas extraction? Here and then for others later on in the Rhine-Meuse as well.
Yeah, that's an excellent question. I think it's one of the holy grails that we try to unravel everywhere, I would say, right? Disentangle the signal that we measure and that we see at the surface. So no, we're definitely not that far that we can already put percentages to it. It would be great if we can in a few years from now, but also that would be, I think, ambitious. Yes, the oil and gas extractions are very sensitive, and I mean, in a country like Nigeria, you need to go around in armored cars protected by military if you're not Nigerian, let's say. So it's a hard-working, very difficult to work. And yes, there's been assassinations if you are blaming oil companies and stuff. So this is a very sensitive topic. So we try to stay a bit clear from that because we don't want to have any of that, of course, in the project. Fortunately, I would say, looking at Lagos, we think that the majority of the signal is not coming from the hydrocarbon extraction, but actually from other drivers. Extraction of groundwater, for example, that is the main culprit, I would say. Yeah. And that's much more safe to talk about.
Thank you. Maybe another question? Yes?
In looking at some of the building damage that you showed, it looked like there was a substantial differential subsidence, and the scale of the geologic information you'll need to assess that is daunting.
Yeah, I that's a good point. I agree. Can I go back? Is that still working? Just to. I mean, I think part of what we see here is not only to blame on subsidence. There's probably also, let's say, errors in construction or foundation, etc. Definitely, because yeah, you wouldn't expect this amount of differential subsidence of a whole building to tilt. So that is true. So I agree with that. What we do see also, it's not highlighted in this presentation, is an increase in the amount of floods in the city taking place. Pluvial floods mainly. So we are starting to create this bathtub effect of not being able to drain. But also that is, of course, also linked to, let's say, poor drainage infrastructure, etc. So yes, we are looking at a mixed signal, and that's part of the challenge to unravel.
Yeah, thank you. Another question here.
Well, thanks, Philip, for showing this presentation. I think it's very important to also focus on this part of the world. Regarding data, I also have another suggestion, because a lot of European engineering firms, they are involved in not so much in let's say, prospecting for the hydrocarbons, but more in installing the infrastructure, the harbors, the roads, pipelines, etc. And I know, for instance, a Dutch company, Fugo, which has headquarters nearby, they did a lot of cone penetration testing in Nigeria. I've even seen the data in Leidschendam. So I know that at least part of this data is in the Netherlands. And yeah, maybe it's also an idea to have a chat with them, so that you have at least some data of the upper 50 meters or so.
Yeah, excellent. Thanks. Great suggestion. Let's talk more.
Well, I guess there is an owner of the data, but...
Thanks, Philippe, for this presentation. In terms of correlating subsidence with hydrocarbon production, indeed, as you say, in Lagos, there's none, so that's quite easy. But even for around Port Harcourt, I just searched on the internet for the outlines of the oil and gas fields. They're simply there. So I think it should be straightforward to do that. There's no secrecy about that. And correlating even the outlines of the hydrocarbon water context with the substance as observed in INSAR should be straightforward and not get you into any ground visits on site in Nigeria that may pose some security issues indeed.
Yeah, that's another very good suggestion. Thanks for that. And indeed, the outlines are available. It is the production, of course, that is being protected and unavailable. There is, I think, some bulk numbers, but they're not specified to the individual wells and the individual place in the field. So that, but we can try to go forward with trying to predictive model or exactly. Thanks a lot.
Thank you, Philippe.
Thank you.